For a while, there have been efforts to add some form of container support into the CloudStack. This is going to change with CloudStack 4.14 as it is coming up with a Kubernetes integration plugin called CloudStack Kubernetes Service, which would allow users to run containerized services using Kubernetes clusters through CloudStack. CloudStack Kubernetes Service plugin comes up with a number of APIs and corresponding UI to provision Kubernetes clusters and manage them. It also allows managing different versions of Kubernetes for deployment of such clusters. It uses kubeadm tool for provisioning of clusters, uh, and CoreOS template will be needed for deploying node VMs for these Kubernetes cluster. For faster and partial offline installation or the provisioning of Kubernetes cluster, it uses ISOs having uh, Kubernetes binaries bundled into it. To create such ISOs, a bash script has been added into CloudStack common package, which is named as create Kubernetes binaries ISO. By default, plugin will be disabled in a fresh install of CloudStack 4.14 or its upgrade. Let's see a short demo how we can enable CloudStack Kubernetes Service plugin and use it to deploy Kubernetes cluster. We have a KVM based environment running here. So let me log in as admin. Right now we are seeing nothing new. So as mentioned in the documentation, we would need to enable Kubernetes service plugin using this global setting. Currently it is set to false, so we will change it as true. We need to restart our management server now, so let's do that. Server will take some time to get restarted. Environment is up again, so let's log in again. As we can see now, we are getting a new option for Kubernetes service after enabling our CloudStack Kubernetes service plugin. If we go there, we get these options where clusters will be listed and option to add a new cluster. Going through this view, we can also see different versions we have added for in the our plugin. So let's try to deploy a cluster now. For this, we need to check what we need to do here. Firstly, we would need to add some versions of Kubernetes. Either we can create these ISOs using this script, or we have this option of already existing uh, versions that have been uploaded by the community. Let's take this version and try to add it. Kubernetes cluster with CoreOS needs at least 2 GB of RAM and 2 cores of CPU. So we will add that here. This will take some time. It is still in creating state. So till the time ISO is being downloaded into the storage, it would remain as creating. Let's add another version for future upgrade. So let me copy this link. If we go into ISO's view, we can see there will be some new ISOs that are going to be downloaded. This is at 3%, so we have to wait till this gets done. Meanwhile, we can add our core OS template. So as it is a KVM based environment, we need to get links for KVM template for core OS. These can be downloaded from OpenVM. We'll take this template, set its properties. We need to register it as a public template. We have to wait till this download and installation of template is complete. So our template is downloaded now and it is being installed into the secondary storages. Uh, let's also check our versions, are they ready or not. So as you can see, ISO state is ready. For now, these Kubernetes versions can only be managed and added by an admin account. So we get this form for adding a new version, and while going into the version, we also get option for deleting a Kubernetes version and editing to set it as enabled or disabled at a time. So this is done now. We need to set our newly registered template as template for our plugin. So we need to copy this name and we need to set it into global setting. Here, CloudStack Kubernetes cluster template name.kvm. Once this is set, our Kubernetes service plugin is now ready to deploy Kubernetes clusters. So let's log out from admin account and try to provision a cluster using a normal user account. We are logged in as a user account and we are seeing same Kubernetes service tab. We get this option for add Kubernetes cluster where we get these parameters such as name, description, zone in which we are trying to deploy our cluster, version we want to use while provisioning our cluster, service offering, and node root disk size, network, cluster size, how many nodes should be there. This is particularly to the worker nodes that will be in our Kubernetes cluster. We can also pass some SSH key pair to access our node VMs directly. And when we use this 1.163 version, we also get this option for HA enabled cluster. Right now, CloudStack Kubernetes Service plugin provides HA enabled clusters with multi-master setup only for Kubernetes version 1.163 and above. So let's try to deploy a cluster. Let's deploy this cluster now. We name our cluster something. For now, we are using 1.15 version. So as we can see, it shows only those service offerings that are supported by Kubernetes version, because we have set number of CPUs and amount of RAM there. We can also set this node root disk size. So while deploying node VMs, CloudStack will increase or set whatever disk size we set here. So let's set it as 10 GB. We can also pass a already running network, or we can set it as blank. So CloudStack will deploy a new network for this cluster. For now, we are trying to deploy a cluster only for one worker node. So by default, CloudStack Community Service will deploy one worker node and one master node for a cluster, for this cluster. So let's deploy this. This will take some time, depending upon the size of cluster we have deployed and the type of environment we have. It takes around 5 to 10 minutes for deploying a cluster. Right now, cluster is showing as creating. So let's try. It is moved to starting state now. So if we try to go in right now, it will show some of the options and details about the cluster. It shows our access tab, how we can access our Kubernetes cluster. These are the uh, instructions that we need to follow while accessing our cluster. We can see currently master node VM is already in running state, and our worker node 1 is getting started. So we need to wait for a while. Both the nodes are now in running state. We also get this option for managing firewall for our cluster. So by default, CloudStack will provision some firewall rules for the cluster, as we can see here. We get these rules for start port 2222 with number of nodes for accessing node VMs through SSH, and we get this another rule for port 6443 for accessing API endpoint of the cluster. Cluster is still in a starting state, as CloudStack is trying to deploy all the Kubernetes binaries into node VMs, and once it will be done, it should show as running. As we can see, cluster has been created, so we get this notification. If we refresh our view, we can see it is showing as running. We have shown while deploying a Kubernetes cluster, uh, CloudStack creates new firewall rules, and it also creates a load balancing rule for API. And as we know, it will need a network, so it deploys this network generally with the name of cluster dash network. So now we can try and see what all options we have for managing and accessing our cluster. So we get some of these action items. We can stop our cluster, destroy, download its cluster config, scale our cluster, and upgrade cluster. So let's try to scale our cluster first. We can scale our cluster for its service offering and also for uh, worker nodes or cluster size. Right now it is 1, so let me try to scale it for 2 worker nodes or 2 size. Scaling takes some time as it will try to add a new node VM into the cluster. As we can see, a new node has been added, and our cluster is showing as a scaling state. This will take some time. Let's check our cluster now. So let's refresh. It is scaled now. We can see size has been changed, number of cores and memory have been changed, and we are seeing 3 node VMs, 1 master and 2 node VMs. Same VMs will be listed here. Now let's try to access our cluster. We have this access details. First we need to download clusters kubeconfig file from details tab. Then we need to download kubectl tool for our OS, and we can use following command pattern to run different Kubernetes commands on our cluster. So let's download kubectl. Also download kubeconfig file. We have now logged into our dashboard. We can access different namespaces and whatever else we can do with normal Kubernetes cluster. So let's try to create a new deployment now. We will try to add an Nginx deployment here, and let's see if it works. So our Nginx is running now. Service is at port 32035. We will need to add this port into our firewall, and then maybe in load balancing or port forwarding. So let's add it here. We will forward this port to 8888. So I am adding a new firewall rule, and in the load balancing now I will forward my 8888 to 32035. I will use both the worker nodes. Once this is done, I should be able to access my Nginx service For accessing that, I need to know the IP for my network. So my network is T1 network. So let's go into network and find its IP address. It is 10.135.164. So as you can see, Nginx is up and running. So with minimal manual setup, we have been able to deploy containerized instance of Nginx through CloudStack Kubernetes service plugin. Now we can see more uh, what more we can do with our Kubernetes cluster. We have this option for upgrading Kubernetes cluster. So right now we are using 1.150 version. So as we can see, we have already added multiple versions. See, a normal user account cannot add a new Kubernetes version. Let's try to upgrade our cluster now. It will show only one version because there is only one upgradable version right now. So let's do it. This will take some time as all the node VMs will be needed to be upgraded to a new Kubernetes version. If we can see in the uh, cluster list, it will show as upgrading. Let's wait for a while. Cluster is upgraded now, so we can see it is showing as running now. We can see version has been changed here. If we check our check the version through kubectl, it should also reflect the same. All the nodes are now in 1.16.3 version, so upgrade has been successful. Since we have upgraded, we might need to re-download our retrieve our token. So after upgrade as well, our dashboard is working fine. We can check our nodes. Version here as well is showing 1.163. So that is about upgrading a Kubernetes cluster. Now we can also perform operations like stopping our cluster, which would ask for confirmation. It will take some time as it will try to stop all the node VMs. As we can see, two of the VMs have already been stopped and our cluster has been stopped successfully. Similarly, we can also destroy our cluster. This will delete all the resources that cluster created while deployment. Like all the node VMs will be deleted one by one. Network will also be shut down and deleted, and the cluster has been destroyed successfully. So that's it. We had these different options for deploying clusters without much manual configuration through our new CloudStack Kubernetes service plugin in CloudStack 4.14. One thing I would also like to mention that for we have couple of new global settings for managing our Kubernetes service that can be seen here. We can search for Kubernetes. So we have some experimental features that we can enable. They are basically related to Docker private registry. We can set network default network offering for our Kubernetes service that will be used for deploying cluster. We have different timeouts such as scale timeout, start timeout, and upgrade timeout. This will be time in seconds that will be taken by cluster or CloudStack as in while performing these operations. We can set template for different hypervisors, and uh, lastly, as we have shown earlier, we can set our Kubernetes service plugin enable or disabled using this global setting. That's it, guys.